In the previous video, we talked about the fundamental theorem of calculus, the one that I like to call part one. Um, it's just how I learned it, how it makes sense in my head. So now I'm going to give you guys the fundamental theorem of calculus part two. And I really like the technique. I learned this technique at a workshop I went to a bunch of years ago. But I really like this technique in helping you guys solve these types of problems. Okay, so we need to show that this side equals that side. Okay, so let's work with our left side. The left side, the antiderivative of 2t is not t because I'm not integrating. I'm integrating with respect to t, so it's t squared. And I'm going to evaluate that from 1 to x. So that means that I have x squared minus 1, which is what I have there. So symbolically now, okay, think about that fundamental theorem of calculus, part one, where symbolically we said the antiderivative of small f of t was some big F, okay, and remember you go from x to a. And you probably want to just put a little caveat in there where the derivative of big F is equal to the small f, okay? So this idea is, I think it is just phenomenal. I think it's probably one of the best things that I've learned from that workshop I went to. That and derivatives of inverses. Okay. So now what we're going to do is we're going to find the derivative of this. So your steps are you write your antiderivative, you write this in symbolic form. So remember, writing this in symbolic form is this right here. Okay, because a lot of times I'm going to be giving you guys functions that you don't know how to take the antiderivative of. And then we take the derivative of that function with respect to x. Okay, so we start off and we have this function. And when I'm trying to take the antiderivative of this, I don't know what that is. So I call this a big function, big F of x minus big F of 2. Okay, and that's just our notation. You don't have to write that where f prime of x equals f of x the whole time. That's just our understanding. Now I take the derivative of this with respect to x. So I take the derivative of this with respect to x. So now what I have is I have the derivative of this craziness here that I don't know how to take the derivative of, but I can say that this is that now equal to the derivative of this function. Okay, well, what's the derivative of f of x? That big F of x, well, that's small f of x. Derivative of big F of 2, well, that's 0, because that's some number. So this is now equal to f of x. F of x is hanging out right here. So this equals 2 plus cosine of x. There's no dx attached to it, okay? It's just the function that you see there. Again, doing the same thing, okay? So writing this thing. Notice now how I have a function up there. I say that this is equal to big F of x squared minus big F of 2. Now I take the derivative of both sides. Okay, So I take the derivative of both sides. And when I take the derivative of both sides, the derivative of this side is small f of x squared times by the derivative of the inside function. It's a chain rule. Minus big F of 2, well, that's going to be 0. So then this whole thing equals, all right, I have this function here, 1 plus x squared to the third power times by 2x, written another way, 1 plus x power to a power, I multiply my exponents, we get that. Okay, again, it's the same process. I know that I now need to write this. This one's a hefty one, because now I have two functions. Okay, I have a function in my upper limit, a function in my lower limit. Well, that equals big F of the sine of x minus big F of x squared plus x. So now when I take the derivative with respect to x, I have small f of the sine of x times by the derivative of the inside minus small f of that function times by the derivative of the inside, which is 2x plus 1. So now this equals the cube root of the sine of x plus the sine to the fourth power of x. Now on the outside, this is on the outside. I'm going to put it in parentheses so you realize it's on the outside. Minus, I'm going to put this term below. It's not dividing. I just ran out of space. My 2x plus 1, I'm going to put that in front. And the cube root of x squared plus x, substituting that in for that t, plus x squared plus x to the fourth power. So something that I feel like I forgot to highlight in this video. Basically, all you're doing is, let's go back to our first example. Hopefully you're noticing when I take the derivative of the integral, they kind of undo each other. It's like adding and subtracting, they undo each other. My final answer looks a lot like what was in the inside here, just with an x. When I got to this example, same thing. This, if I would have written it correctly, that should be a 5, is the same thing as that, but now I have the derivative. If I have a function there, I have the derivative of it outside. On this one, again, the same thing. I have function being evaluated at whatever my function is, times by the derivative of that function that I plugged in. Same thing over here, okay? So that's the idea behind the fundamental theorem of calculus part 2. So now you know both fundamental theorem of calculus, and I just want you to know my cat really liked this video. She's been running around back and forth behind me. Right now it's December of 2020, end of December, and she's running around. I don't know what she's doing, but for those of you that stayed on, maybe you heard her in a couple of the videos that I've been recording over our Christmas break. Anyway, make sure that you are ready for class for all that we are going to be working on.